This is a tour of the Swarmathon Rover interface. After you have set up your Swarmathon environment following the README instructions in GitHub, you will find under your Rover workspace is a shell script called run.sh. This script starts the Swarmathon interface. There are two main panels in the GUI, the sensor display and simulation. The sensor display panel allows you to visualize the output from your rover. The simulation tab allows you to set up a gazebo Swarmathon simulation. Under simulation setup, you can specify the type of simulation you want to run. Preliminary rounds have 3 rovers, but final rounds have 6 rovers. The target distribution, uniform, random, clustered, and power law. And the ground texture, which allows you to choose the background against which your rovers will be looking for targets. I'm going to create a simulation with a gravel floor, 6 rovers, and a clustered distribution of targets. Click Build Simulation to create a gazebo world with these parameters. An advantage of using ROS and Gazebo is that the simulated rovers behave just like the physical rovers. Here we see April tags modeled in Gazebo. Each April tag is unique. The rovers we created show up in the rover list. If we had connected physical rovers, they would show up here just like the simulated ones do. When I select a rover, information about its virtual sensors is displayed. The model files that define objects in the simulation are in the rover workspace under miscellaneous models. April tag models start with A. Greek letters define rover models. The sensors for rover alpha are defined under alpha/model.sdf. Simulated sensors have error just like those on the physical rovers. For example, here I can see the IMU unit has a drift of 0.01 and a Gaussian noise standard deviation of 0.01 as well. Clicking on the sensor display, we can see a visualization of sensor data coming from the rover. Notice that the 3 ultrasound sensors detect the rover in front of this one. Use the ultrasounds to avoid collisions with other rovers. The rover in front of us is about 2 meters away. Currently, this rover is being controlled with a joystick. I'm using an Xbox 360 controller to drive the rover around and try to find some tags. The camera data allows the rover to detect tags. The target detect function under source target detection, source target.cpp, this source file contains code that allows the rovers to detect targets, to detect the April tags. The IMU provides position data, orientation, and force. The rovers are represented as a cube with red on the bottom and blue on the top. We are looking directly down at the rover, so we can't see any red. The IMU data is integrated with the GPS and encoder sensors in order to keep track of the rover's position. The map shows where the rover is being. Green is encoded data, red is GPS data, and white is a combination of GPS, IMU, and the encoders. The IMU can also be used to detect problems. For example, if the rover starts to flip, that can be detected using the IMU. You see how the IMU visualization has changed. Informational and debugging messages are displayed in this log window. As fun as it is to drive the rover around with a joystick, it's even more fun to put them in autonomous mode. Now the rover will implement the strategy for finding April tags that you have encoded. The code you received has a fairly simple random walk coded up. The code is in source mobility.cpp. You'll probably use this file for much of the logic you build into your rover, but feel free to modify and create code throughout the system. The simple random walk that we've developed uses a state machine as its controller. Now all the rovers are implementing autonomous search. Now all the rovers are searching for tags. The code you have been given allows the rovers to avoid each other, detect April tags, and return to the collection point. The source code for obstacle detection is in source, obstacle detection, source, obstacle.cpp. The GUI source code is on a source RQT Rover GUI. Source. The GUI is written in Qt C++. I hope you'll modify and improve the GUI to better understand how your rovers see the world, and so you can understand how your rovers are performing. This code is still under development, so watch the GitHub repository for new releases and bug fixes.